Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 2 in the Information Disclosure module titled Information Disclosure on Debug page. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs. And then do a search on information disclosure, vulnerabilities, and select lab number 2 titled Information Disclosure on Debug page. All right, let's get started. This lab contains a debug page that discloses sensitive information about the application. To solve the lab, obtain and submit the secret key environment variable. All right, so the target goal over here is to find the debug page and then obtain the secret key environment variable from the debug page. All right, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. Okay, so while this is loading over here, let's click on a few pages. Let's say view details, for example, over here. And then what I'm going to do is I'm going to go to target and I'm going to look at the URL of the application. So it was 0ABE, which would be this one right over here. And I'm going to see all the folders and pages that it identified. So if you have the pro version of Burp, what you could do is right click and then under engagement tools, click on discover content so that it could crawl the application and discover new URLs, but that's not necessary for this lab. Over here you could see it already identified a few folders and the pages under those folders, and one of them is CGI bin. So if we look over here, there's a phpinfo.php page. So this is very interesting. Let's right click and then copy the URL and just visit it over here. So this has a bunch of information about the application. What we're looking for is a secret key, and here we go. So let's copy that and submit the solution. Click OK. And here we go. It says, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. First thing we're going to do is send that request to repeater. So if we go to proxy, it was this request right over here, and we'll send it to repeater. All right, so if we go to our script, we need to import all the regular libraries that we use. So the requests library, the sys library, the URL lib3 library, and then we'll also import the regex library because we're going to need it in order to extract the secret key from the response. And then we're going to disable insecure request warnings. So disable warnings, URL lib3 dot exceptions dot insecure request warning. And then we're going to set our proxy settings. So proxies is equal to all HTTP traffic should be sent to where Burp is installed. So that would be on HTTP 127.0.0.1 port 8080, and it's not where Burp is installed, it's where Burp is running. Next, all HTTPS traffic should be sent to the same place. So HTTP 127.0.0.1 port 8080. And then we're going to say if name is equal to main, then call the main method, and we'll define the main method right over here. So def main, if the length of the command line arguments is not equal to 2, that means the user ran the program incorrectly, and so we'll print the usage instructions, which is the name of the program, and then the URL. And we'll take the name of the program from the command line argument. So sys.argv 0. And then we'll also print the example instructions. So example, name of the program, and the URL, so www.example.com. This is just an example URL. And then again, we take the name of the program from the command line argument, and we exit the program because the user ran it incorrectly. All right, this looks good. Now let's assume the user did run it correctly. The first thing we're going to do is create a sessions object. So request.session, and then we'll create a variable called URL, and we'll take the value of URL from the command line argument, so argv1, and then we'll call a function called obtain secret key, which takes in the session object and the URL. All right, this looks good. Now let's define that function. So def obtain secret key, session object, and the URL. The first thing we're going to do is save the URL of the vulnerable request. So we'll name that php info URL. So this space should definitely not be available to any user in the production environment. However, it's made available, and that's the information disclosure vulnerability. So the URL would be the URL of the main application plus this path right over here. So let's copy that. And actually, let's hit send over here before it times out. So let's put this in here. And then next, we just perform the request. So ask.get, because it's a get method, it takes in php info URL. We set verified to be equal to false and proxies to be equal to proxies. And then we're going to save the response in a variable called res. And we're going to confirm if we properly exploited the vulnerability by looking for a status code of 200, which means that we did find the PHP info page. If we get that, then we're going to print successfully exploited vulnerability. Otherwise, we'll print could not exploit vulnerability, and we'll exit the program because the exploit failed. So sys.exit -1. Now, after we identify that we successfully exploited the vulnerability, the next step is to extract the secret key and output it on the screen. So we're going to create a variable called secret key, and it'll be equal to re.search. So we're going to do a regex search. And what we're looking for over here is a string that matches the regex expression that we're going to write right now, and that's going to be in the response of the request. So if you look at secret key over here, and we identify how many characters this is, let's copy it and put it in here. This in itself is 32 characters. So what we're going to say is we're looking for so we're going to say we're looking for 32 characters, and the characters can be integers, so 0 to 9, or lowercase letters, or capital letters. But we're looking for 32 characters right after each other. Now, this could match on pretty much anything that only has alphanumeric characters. And so what we're going to do is we're also going to add a space after, because you could see over here there's a space right after this one. And so for sure, it'll match only on that string. So let's save this. This looks good. And now we'll print the following is the secret key. And we'll output the secret key. So secret key dot group 0, because we just want to output the first instance of it. And here we go. Let's save it and save notes as well. Now let's see if our application timed out, and it did not. All right, so what we're gonna do is terminal, new terminal, Python 3, information disclosure lab 02. .py and the URL of the main application. So let's copy that, paste it in here and remove the trailing slash and hit enter. And we get an error. And I know why. Over here, we missed the closing bracket. Let's save it. So our regex string was incorrect. Let's run it again. And here we go. It says successfully exploited the vulnerability, and then it outputs the secret key that it finds in the PHP info page. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at another case of an information disclosure vulnerability.